Grade 5. Math. Insert decimal numbers. How do we insert a decimal number between two consecutive numbers? First, let's remember the meaning of consecutive numbers. Consecutive numbers are numbers that follow each other, next to each other, after each other. For example, 7 and 8, like they are whole numbers here, and they can be decimal numbers as well, like 3.5 and 3.6. You see how the 10th digits are consecutive? 5 and 6 follow each other. Also, we can have hundreds, like 7.23 and 7.24. The hundredth digit here are consecutive. Here we have 3, there we have 4. So the numbers are consecutive. They follow each other. So if we have consecutive numbers, like these 3 examples, we can't insert a decimal number between these consecutive numbers unless we put point zero or useless zeros and start dealing with decimal numbers. Here between 7 and 8, we can't find any whole number between 7 and 8, but we can find decimal numbers, infinity of decimal numbers between them. So you should add point zero here and point zero there and start dealing with tenths digits. So here we say 7.1, 7.2, 7.3 till 7.9. In the next example, you can put 0 here and 0 there and start dealing with 3.51, 52, 3.53, and so on till 3.59. And in the third example, you can put a 0 here and 0 there and start dealing with thousandth digits. And you can insert 7.231, 232, and so on. Let's see these examples on the number line. Example 1. First question. Write above the letter A the corresponding decimal number. You can see that the letter A is included between 1.1 and 1.2. These numbers are consecutive. The 10th digits are consecutive. So, if we want to put numbers between them, we should add useless zeros. Now we have 1.10 and 1.20. We divide the part between them in 10 equal parts and we start talking about hundredths digit. So we have 1.11, 1.12, 1.13. So A is located exactly at 1.13 and the number is 1.13 or 1 and 13 hundredths. Second question. Give a decimal number included between 1.4 and 1.5. Give a decimal number. There are many decimal numbers between them. But you can't see them unless you add useless zeros and you start dealing with hundredths. Let's see this in the number line. This is 1.4 and this is 1.5. For example, I chose to give this number. You put useless zeros. You start counting 1.41, 1.42, 43, 44, 45, 46, 47. So this number is exactly 1.47, or you can say 1 and 47 hundredths, THS. You can give other numbers like 1.41, 1.42. The easiest one is to give the next number, which is 1.41. Example 2. Choose from the list a number included between 4 and 5. 4 and 5 are consecutive whole numbers. And in the list, we have 3 decimal numbers. So we should add useless zeros to start talking about decimal numbers between 4 and 5. Let's start with the first number, 3.8. Can this number be included between 4 and 5? No, because the whole part in 3.8 is 3, which is less than 4, so the number is less than 4.0 and not included between 4 and 5. Now, the next number is 5.1. Can 5.1 be included between 4.0 and 5.0? No, because the whole part is 5, which is more than 4. But is it less than 5.0? We should compare the decimal parts here. 1 is greater than 0, so the number is greater than 5.0, not included between 4 and 5. For the third example, 4.9, can this number now be included between 4.0 and 5.0? Yes, it is. The whole part is 4, so it is more than 4.0, and it is less than 5. 9 is greater than 0, so the number is included between 4.0 and 5.0 since it is greater than 4.0 and less than 5.0. Example 3. Choose from the list a number included between 9.1 and 9.5. These decimal numbers are not consecutive. We can insert 9.2, 9.3, and 9.4 between these two numbers. But in the list, you can see that they gave us numbers with hundreds digits, 2 digits after the point. So we should add a useless zero here and a useless zero there and start talking about hundreds. Let's start with the first example, 9.65. Is this number included between 9.10 and 9.50? No. The whole part in 9.65 is 9. So we should compare the decimal parts. 65 is greater than 50. So 9.65 is greater than 9.50, not included between them. For the next number, 9.09, also the whole part is 9, so we should compare the decimal parts. We can notice that 09 is less than 10, so the number is less than 9.10, not included between 9.10 and 9.50. Now for the third example, 9.24, the whole part is 9, so we should compare the decimal parts. 24 is included between 10 and 50. Therefore, the number is included between 9.10 and 9.50. Example 4. Choose from the list a number included between 18.24 and 19. These two numbers are not consecutive. We can insert many numbers between them. In the list we have 18.1, 19.25, and 18.3. So we should put 0.00 in 19 to start talking about decimals with 2 digits after the point. Let's start with 18.1. Is 18.1 included between these two numbers? First, we should add use a 0. Is 18.10 included between these two numbers? It is obvious that the whole part in 18.10 is 18. So, to know whether this number is less or greater than 18.24, we should compare the decimal parts. 10 is smaller than 24. So the number is less than 18.24, not included between them. Now the next number, 19.25. Is this number included between 18.24 and 19.00? No. Since the whole part is 19, we compare the decimal parts. 25 is greater than 00, so the number is greater than 19.0, not included between them. For the third number, we should put use the 0, 18.30. The whole part is 18, so we should compare the decimal part, 30, with the decimal part in 18.24. 30 is greater than 24, so the number is included between 18.24 and 19. Example 5. Complete with a convenient decimal number. Now we will insert a decimal number. Between 27.1 and 127.3, we have infinity of numbers between them. Since we have different whole parts, we can choose whole number or a decimal number between 27 and 127. You can say 28. You can say 100. Or for example, a decimal number like 27.2. Or you can say 38.5. Or maybe 100.9. You have many examples. Example 6. Complete with a convenient decimal number. We should insert a decimal number between 5 and 5.6. We should add the use of 0 in the decimal part and choose a decimal number between 5.0 and 5.6. Since the whole parts here and there is 5, we should change the decimal part so we have 0 here and 6 there. We can write 5.1, 5.2, 5.3, 5.4, and 5.5. The last number, the greatest number, is 5.5. You cannot write 5.6. Example 7. Complete with a convenient decimal number, 12.6 and 12.7. In these two numbers, the whole parts are equal and the decimal parts are consecutive. So we should put a use of 0 in the decimal part and start talking about hundreds. We can choose any decimal number between 12.60 and 12.70. So between 60 and 70 we have 61, 62, 63 till 69. So we can write 12.61 or maybe 12.64. And the greatest possible number is 12.69. You cannot write 12.70. Insert a decimal number. Let's repeat. If we have different whole parts, for example 27.1 and 127.3, we can give any decimal number or whole number between these two numbers, for example 100.5. But if we have equal whole parts, like 5 and 5.6, we should add useless zeros and give a decimal number here included between 5.0 and 5.6. We change the decimal parts, we start counting, we can give 5.1, 5.2, 5.3 till 5.5. So for example here, 5.3. Another example, 12.6 and 12.7. Here we have equal whole parts. 6 and 7 are consecutive, so we should add useless zeros and start counting 61, 62, 63 till 69. For example, we can give 12.65. And thank you.